Welcome. In this video, we're going to be integrating the derivatives of the inverse trig functions. All right, so here, just as a review, here are all the derivatives of the inverse trig function, and notice that the derivative of arcsine, the derivative of arccos are the same thing except for the sign. Likewise, the derivative of arctan u and the derivative of arccotangent u are the same except for the sign. And the derivative of arcsecant u and derivative of arccosecant u are the same except for the sign. Right? So the derivative of arcsine u, arctan u, and arcsecant u are positive. The derivative of arccos u, arccotangent u, and arccosecant u are negative, right? But otherwise, they're exactly the same, right? So the derivative of arcsine u is going to be 1 over the square root of 1 minus u squared du dx. The derivative of arccos u is the same thing except negative. The derivative of arctan u is 1 over 1 plus u squared du dx. The derivative of arccotangent u is the same thing but negative. And then the derivative of arcsecant u is 1 over the absolute value of u times the square root of u squared minus 1 du dx. And the derivative of arccosecant u is the same thing but negative. All right, so now let's look at the integrals. All right, so we're going to be given the derivative, and we want to get back to the original function, which is an inverse trig function. All right, so let u be a differentiable function of x, and let a be greater than 0. All right, so we have the first one. If we have the integral of du over the square root of a squared minus u squared, that's going to be arcsine u over a plus c. Now it might be that maybe u squared is written as a something squared, and maybe a squared is written as a something squared. But more likely, especially the a squared, that's just going to be a number, right? And that's not going to be written as a something squared. So our first helpful hint is, first thing we're going to do is we're going to be rewriting these as perfect squares, as a something squared minus a something squared. Right? And the u is a variable and the a is a constant. And then below I have the negatives of all of those. So if we have the exact same thing but negative, then that would be arccos u over a plus c. If we have the integral of du over a squared plus u squared, that's going to be 1a arctan u over a plus c. And if it is negative, we'll have the exact same thing except, so if you have the exact same thing but negative, it'll be 1 over a arccotangent u over a plus c. Right? So the reciprocal ones are, or not reciprocal ones, but the related ones are the same except for the sign. And then if we have the integral of du over u times the square root of u squared minus a squared, that's going to be 1 over a arcsecant absolute value of u over a plus c. And then if we have the same thing but negative, then that would be 1 over a arccosecant absolute value of u over a plus c. All right. Now, some of these may involve substitution. All right. Maybe we don't have the du part. Right. We can be missing a constant. That's okay, right? And then we know that we have to solve for that missing constant on the other side, right? So some of these will involve some substitution. Most of these will involve rewriting a little bit, all right? But then once you get the hang of it, once you recognize that it is an integral involving an inverse trig function, they're not that difficult. And I did put the formula for each one of them so that you could kind of look at that and remember. All right, so if you've got in the denominator the square root of something minus, and then the other something is a variable squared or a coefficient in variable that could be squared, then that's going to be, when we integrate, that's going to be arcsine. All right, so first of all, let's take care of my helpful hint there, which was make each a something squared. All right, so the x squared, that is already is a something squared. So I have dx, I'm sorry, I don't need the du. I don't need a substitution on this one. So we have the integral of dx over the square root of 2 squared minus x squared. All right, so let's identify. Always a good idea when you're dealing with these to identify your u and your a. Our u is x, right? It's an x squared. We have the derivative. That's not a problem, right? Because the derivative of x is 1, right? So no problem there. And it might not be a bad idea to just put that there. Dx is 1. So we're not missing anything, any part of the derivative of the inside stuff, right? And then the a is 2. All right, so actually we can go right to writing the integral here. This is going to be arc sine over x over 2 plus c. That's all there is to this one. It was recognizing that this was arc sine, that the integral was going to be arc sine, and then just rewriting it so you had a something squared minus a something squared, and identifying the u and the a, plugging it in. Right? Number 1, done. All right, let's do the next one. All right, so again, I have the formula over there on the side there. This is an arc tangent. Right? So in the denominator, we got, it doesn't look like it's a something squared, but anything can be a something squared, right? So a something squared plus a something squared, right? As long as the variable is squared, we can always make the constant a something squared. That is going to be, when we integrate, that's going to be arctan. All right, so now let's rewrite this. So we have dx over square root of 2 squared, all right? So now that's a something squared, plus 9x squared, that's going to be 3x squared. As long as the variable can be squared, you can always make the constant a something squared, just using square roots. Now let's identify all of our parts and make sure we got everything. All right, so u is going to be the 3x. The derivative, right, of 3x would be 3dx. All right, we have a problem there, right, because we don't have a 3. Right, so we are going to use substitution here. Right, so we're just going to replace that dx with a 1/3 du equals dx. And that does mean we'll replace the u with the 3x. The only other thing we need to identify is the a. The a is the square root of 2. Right, and that doesn't get rewritten. Right, so let's rewrite this. So we can put the 1/3 outside the integral. So we have 1/3 du in the numerator, and then we have the square root of 2 squared plus u squared. All right, and so now we will write our integral, and I just kind of noticed something. I hope I put on the last one a plus c. All right, so we're going to integrate. All right, so this is going to be 1/3, and then we have the a, so times 1 over the square root of 2 arctan. Until we do the substitution, it's u over the square root of 2 plus c. All right, now we can simplify that, and we can substitute back, because we do need to substitute back. So that's going to be, and I'm going to write this as an equation. I really should write this as an equation. F of x equals 1 over 3 square roots of 2 arctan, and that was, so I'm going to replace the u with a 3x over the square root of 2, and then plus c. That's fine, right? Or we can rationalize the denominator if you want. I'll do that just in case you saw it as a rationalized denominator somewhere. All right, so that is fine answer, or you can write it as f of x equals, so if we rationalize, this would be square root of 2 over 6 arctan. This would be 3x times the square root of 2 over 2, and then plus c. All right, but I don't care whether it's rationalized or not. Not a big deal. Let me see if I remember the plus c on the last one. I did. All right, and I really should probably write this as an equation. So f of x equals arcsine x over 2 plus c. All right, let's try the next one. All right, so now this one is an arcsecant. All right, now we don't see an absolute value bar or anything like that, but that's okay. We have the u. It has this format, right? We have a u and a u squared, right? Let's rewrite that so we see the u and the u squared. All right, so this would be dx over 2x square root 2x squared minus, and let's rewrite the 9 as 3 squared, right? Because we're going to need an a squared. So this one has the variable. So one way you can recognize the difference between arcsine and arcsine arccos and arcsecant arccosecant. Arcsecant arccosecant have the u first, where u has a variable in it, and then minus a constant. Right? And then they have something outside the radical as well, right? And it's the square root of that u squared. All right, so now let's identify all our parts. So the u is 2x, the a is 3. Actually, let's make sure we got the du part. So the du is 2dx. We appear to have everything that we. Oh, we don't have a 2. We don't have the 2 because this is the u right here. We are missing the 2 because that 2 doesn't count. That 2 is the u. All right, so we are missing a 2dx there. Notice I had rewritten this problem. I guess I wanted to make sure I had the u, but now we're missing the du part. But that's okay. We'll use a substitution. And then the a is the 3. All right, so we would have f of x. Let's put it right out in front. Equals the integral of du. Actually, let me not put the f of x in until after I integrate because I've got now u's in here. I don't like to mix up variables. That's not great. All right, so we have, let's take care of the du because we don't have that 1/2. So 1/2 du equals dx. Let's get the 1/2 out there. All right, so, and then the a is 3. All right, so we have 1/2 du, and then this would be u square root u squared minus 3 squared, right? And so that's going to be equal to 1/2, and then that would be times 1 over a, so that's 1/3 arcsecant. And then the u is going to be in absolute value bars. I don't think I left off the absolute value bars. All right, so u. And then the u is over our a, which is 3 plus c. Let's clean that up and let's substitute. So f of x equals 1/6 arcsecant, and the u is 2x, so the absolute value of 2x over 3 plus c. And there we go. All right, so really they're very formulaic. A little bit of substitution if you're missing your derivative. I wouldn't have been missing the derivative if I didn't put a 2 in there because my 2 would have canceled. All right, so now this one, you might not recognize this, but it is arctan. All right, you've got the derivative over something squared plus something squared. It's arctan. All right, so arctan can look very different. All right, so let's use a u substitution here. All right, so u is going to be x minus 3. du would be derivative of x is just 1, so this is just going to be, and the derivative of the 3 is 0. So this is just going to be dx. So we have all of our parts. And then let's identify the a. If we rewrite it, we can identify the a. This is 1 over 2 squared plus x minus 3 squared dx. So the a is 2. All right, so now we'll substitute. All right, so we have the integral of 1 over 2 squared plus u squared. All right, now it's very clear to see that that is arctan. All right, so if you weren't sure with the x minus 3 part, when you substitute with the u squared, it's like, oh, arctan, right? So that's going to be 1 over a, so that's going to be 1/2 arctan, and then u, which is still a u right now, over 2 plus c, and then we'll just substitute back, and we're done with this one. So f of x equals 1/2 arctan x minus 3 over 2, I'll put that in parentheses, plus c. And there we go. That's it. All right, not too bad. This is one that looks like maybe it could be one of those, but let's see. It doesn't follow any of the formats. It does have something squared and plus something squared. 1 is 1 squared. But let's factor here. Because I see that x to the 4th minus 1 could be factored. That's just a difference of squared. X squared minus 1, x squared plus 1, all over x squared plus 1 dx. Hey, we could cancel that out. So now this just becomes the integral of x squared minus 1 dx. Right? And so now you can just use the power rule on this one. So f of x equals x cubed divided by 3 minus x plus c. And so that one wasn't the same at all. All right, that one was not a trig function. It was just pretending. All right, that's going to be the end of this video. I shouldn't have said a trig function, an inverse trig function. That's going to be the end of this video. In the next video, we're going to look at a technique called completing the square. All right, so bye for now.